So this brings us to the end of today's lecture, and just to give a very brief summary, so the first thing we did was to look at kind of subset selection, how we can kind of manually look at all possible combinations of predictors and decide which ones we want to use and which ones not to use. But this was a very tedious process and was also very slow, especially if you do full subset selection and not one of the greedy approaches. So what seemed to be a much better approach was regularization, in particular ridge regression and lasso, where we had an ability to kind of tune down the relevant coefficients of the problem, the prediction problem. We did it by introducing those constraints. So we first started with the hard constraints, where we basically said, well, the kind of L1 or L2 norm of my coefficients is less or equal to some constant C, some budget. And we also looked at the relevant dual optimization problem, where I had soft constraints, where I basically said I took my original loss function here and I was just adding a penalty term, a regularizer times a penalty term, which was effectively just the L1 or the L2 norm of my weights. And we saw that this had very nice properties, and in particular for the lasso, we saw that we could actually get some of the coefficients equal to 0. Now you might ask, why don't I always use lasso? So lasso has the advantage of getting some of the coefficients to 0, which is nice for interpretation, especially if I want to figure out which predictors are more relevant than others. But it is computationally more complicated in a sense. It's easier to run the ridge regression computationally, and this is why often, if it's just about performance and about the kind of test error I'm and I'm not really interested in interpreting which coefficients are better, I'm often using ridge regression instead. So often in neural networks you use ridge regression, whereas in some statistics problems where I want to actually find some interpretation, I look at lasso there. And finally, at the very end, we moved on to high dimensional statistics, and we saw that actually even for standard linear regression, once I have more predictors than observations, the model is not well defined anymore, and I need the regularization just to make it well defined. And that's why something is also called regularization, because it regularizes the inverse, which was infinite before, now it's finite, and now it can solve the problem. So this is really all I wanted to have covered today. And as always, we will go to the tutorials, and you can see a lot of examples, both conceptually as real data examples, where we can look at those things in practice and get some experience, and also kind of interrogate the problem from different angles. So that's all for today. So thanks a lot.